Right. So in organic chemistry, so now we are discussing about types of reaction intermediates. Types of reaction intermediates. Types of reaction intermediates we are discussing. So in every organic reaction, so reactants will form into intermediate, any reaction intermediate, and that intermediate will convert into product. So before forming product, the reactant will form suitable reaction intermediate, and the reaction intermediate will convert into product. So now different types of reaction intermediates are found in organic chemistry. So now we are discussing about that. So right, first one in this, carbocation. Carbocations are one type of reaction intermediates where carbon has positive charge, and carbanion. So where carbon has a negative charge. And the third type of reaction intermediates, free radicals. Free radicals. So if carbon has positive charge, so they are carbocations. If carbon has negative charge, so they are carbanions. If carbon has odd electrons or single electrons, so they are called free radicals. And then a fourth type of reaction intermediate is carbenes. Carbenes. So what are carbenes? Here all carbon with positive charge we discussed, negative charge and single electron also. Now carbenes, carbon with lone pair. If carbon has lone pair, we call it as a carbene. And now the fifth type of reaction intermediate is nitrines. Nitrine. So here in 4 cases we got carbon as a carbon source as reaction intermediate. Now in the nitrine case where nitrogen electron deficient, if nitrogen has electron deficiency, we call it as a nitrine. Nitrogen has electron deficiency, we call it as a nitrines. So it will be like this, suitable. So nitrines can be written like this. So now these are the 4 type of reaction intermediate. So any one of the reaction intermediate will form in a suitable organic reaction. So in every organic reaction proceeds through one of the reaction intermediate. So now we are going to discuss about one by one about these reaction intermediates. Now the first one we are going to start with carbocations. So the first reaction intermediate now we wrote carbocations where carbon has a positive charge. So the example for this, the simple carbocation where one carbon has a positive charge like this. So now the carbocations hybridization can be predicted where carbon is the central atom and its group number or valence is 4. So there are 4 electrons I wrote, and out of 4 electrons here the central atom has positive charge. So I am removing 1 electron from the valency electron, or 1 electron from the group number. Now only 3 electrons now carbon has, and out of 3 here how many elements are attached, hydrogens are attached to central atom? 3 hydrogens. So each hydrogen which is a valency of 1 like this. Now around the carbon how many sigma bonds now? There are 3 sigma bonds. So 3 sigma bonds. So hybridization of organic compounds can be predicted. The hybridization equal to number of sigma bonds plus lone pairs. So here there are 3 sigma bonds and there is no lone pair, 0 lone pairs are there. If number of sigma bonds are 3, hybridization can be predicted as sp2. So 1 s orbital, 2 p orbitals. Total count is 3. So that is equal to number of sigma bonds. Now hybridization of carbocations is sp2 hybridization and shape trigonal planar. Trigonal planar shape. So the trigonal planar shape of carbocation can be written like this. Like this. So the carbocation is a trigonal planar shape. Is a trigonal planar shape of carbocation. And in the carbocation case, around the carbon, count the number of sigma bonds. So there are 3 sigma bonds. So each sigma bond is a result of 1 pair of electron sharing. Like so now around this carbon now there are 3 pairs of electrons are there. So 6 electrons are there. So is it octet? It has 6 electrons, not octet. So to become octet, more 2 electrons it is. That's what carbocations every time during its reactions, they are always trying to gain more 2 electrons. That's what they are electron deficient. So they are electron deficient by 2 electrons. That's why they are always electron pair acceptors. Electron pair acceptors. So the electron pair acceptors are also known as Lewis bases. So they act as Lewis bases. Sorry. So they act as Lewis acid. Electron pair acceptors are Lewis acid. So they're deficient by 2 electrons. They are always trying to accept 2 electrons. So Lewis acids, and the electron pair donors generally Lewis bases. So this is about carbocations and their properties. So carbocations, where carbon undergo sp2 hybridization, trigonal planar shape, and electron deficient they are, and their electron pair acceptors and act as a Lewis acid. So this is one type of reaction intermediates where carbon has positive charge carbocation will show the properties like this. Now the second reaction intermediate now we are going to discuss, that is carbene ion. Carbene ion, second type. So where carbon has lone pair. So the simple example for carbene ion is CH3 minus. This is a one carbon ion where carbon has lone pair. Now hybridization for this carbon, which is a group number of 4 or valency of 4, and out of 4 their minus charge, one extra electron is there, so 5 electrons. So out of 5 there are 3 hydrogens, each hydrogen is valency of 1, and the remaining electrons I am pairing. So now how many sigma bonds here? Hybridization equal to number of sigma is 3 sigma plus 1 lone pair. So there are total count is 4. If count is 4, then hybridization is sp3. So 1 s orbital and 3 p orbitals, which makes a shape tetrahedral. So the expected is tetrahedral. So this is the tetrahedral shape expected. But because of one lone pair, the tetrahedral shape will deviate and it will make the shape of what this is called pyramidal shape. So because of one lone pair, tetrahedral will distort and they assumed as a pyramidal shape. So the pyramidal shape of carbene ion can be written like this. So this is a negative charge, and there are 3 other bonds like this. So this is the pyramidal shape of carbene ion. Now in this pyramidal shape, so the carbene ion properties can be written like this. So there are 3 sigma bonds, 1, 2, 3. 3 sigma bonds means 6 electrons. So each sigma is result of one pair of electrons. So there's 6 electrons plus this negative charge means negative charge nothing but 2 electrons. So totally 8 electrons it is having. So if it already having 8 electrons, so it's an octet. So no need to gain electrons again. That's what this is electron sufficient. And this negative charge or this electron pair is not balanced with the element. That's what this lone pair is always ready to donate for the other element. That's what these carbene ions are considered as electron pair donors. Electron pair donors. So electron pair donors are called Lewis bases. So the carbene ion property can be written like this. So they are sp3 hybridized, and because of one lone pair, the shape is pyramidal shape. And in the pyramidal shape, so they are having one excess pair of electrons. That's what their electron pair donors are electron rich species and act as Lewis bases. So this is the second type of reaction intermediate where carbene ions can be discussed. Third type of reaction intermediate, free radicals. Free radicals. So this generally free radical formation takes place by the type of bond cleavage is called homolytic cleavage. So where hydrogen, for example, there is a one covalent bond between the same elements. So in the presence of sunlight, homolytic cleavage takes place. So means the equal cleavage of covalent bond is called homolytic cleavage. So because of this equal cleavage, each element is getting one electron. So like this odd electron species are called free radicals. So in the similar manner, so carbon can undergo free radical cleavage, where if carbon attached to only hydrogen, in the presence of sunlight, one of the CH bond can undergo homolytic cleavage like this. So now because of this cleavage, one hydrogen getting one electron and the carbon is getting one electron. So this is a free radical called methyl free radical. Methyl free radical. So now one example we are discussing about now methyl free radical and its properties. And now free radical properties we'll discuss. So where carbon group number 4, but here this carbon not having any plus charge to remove electrons from the group number, and there is no minus charge to add the electrons to the group number. That's what it's neutral. So no need to add or remove electrons to the valency shell. Now there are 3 hydrogens here. So each hydrogen which is a valency of 1, 1 electron left. So in the hybridization only we are counting number of sigma bonds plus lone pairs. But here there is no lone pair. Only sigma bonds are there. 1 odd electron is there. So now hybridization equal to, there are 3 sigma bonds plus there is no lone pair. 0 lone pairs are there. So if there are 3 sigma bonds, will make the hybridization of what? sp2. So here the hybridization is sp2 and shape. So sp2 and there is no lone pair also, just 1 electron is there. So sp2 will make the shape of trigonal planar. sp2 without lone pair will make the shape of trigonal planar shape. So the trigonal planar shape of free radical can be written like this. Same as carbocation, but 1 electron left over the carbon. So this is a trigonal planar shape of methyl free radical. And if a methyl free radical shape we wrote, and about its properties. So there are 3 sigma bonds. So each sigma is result of 1 pair of electrons. So here 3 sigma means 6 electrons plus 1 electron is left over the central atom. So 6 plus 1, there are 7 electron species. 7 electrons. So 7 electron means 1 odd electron is there, extra electron is there. So because of this, still it is not octet, and because of this odd number of electrons, so it acts as paramagnetic. Paramagnetic nature. So in the previous case, like carbocation, there are 6 electrons, so 3 pairs, that is diamagnetic. And in the case of carbon ion, 3 sigma bonds plus 1 lone pair is the 8 electron, that is also diamagnetic. But this free radical, because of 7 electron, 1 extra odd electron is there, so it shows paramagnetic nature. But if you consider the octet thing, here still 1 electron is deficient by 7 electrons only there. So 1 electron deficiency is there. So that's what it is also considered electron deficient species. But they are electron deficient by only 1 electron. So that's what they are called highly reactive reaction intermediate. So out of these 3, carbocation, carbon ion and free radical, if you compare, so these free radicals are considered as highly reactive reaction intermediates. Highly reactive reaction intermediates. Right. So this is about the first 3 reaction intermediates we discussed about organic chemistry. Reaction intermediates we discussed first 3.